Whenever we draw a graph, we are basically telling a story of or about how x and y relate to each other. And to understand that story, there are a few keywords we must always know. The first one will be the domain of a function, right? So the domain of a function is simply all the x values you are allowed to use, or just the set of possible x values. So the set of possible x values. Excuse my handwriting. So you can think of the domain as the input, like what am I allowed to plug into the function. If, for example, our function f of x was square root of x, then the domain of this function would be x is greater or equal to 0, because you cannot use negative numbers under the square root or inside the square root, right? So simply the domain tells you what is allowed. So only positive numbers for this specific function. And if maybe we were to draw a function like f of x equal to x squared, the domain of this specific function, let me quickly draw this. So this will be your y-axis, your x-axis. So this graph is something like this. Let me just use G. Yeah. So our graph G of x. So this graph continues going in the positive y direction and also in the positive x direction, negative x direction as well. So this graph, the run is measured on the x-axis and the y measures the rise. So as the run increases, the rise also increases. So that means that the domain of this function and the domain of this function is any value on the negative side of the function and any value on the positive side of the x-axis. Sorry. So this graph, you can think of any number, you can plug in any number or put it as an input and you will get some y value, right? So that means that the domain of this graph is just x is an element of real numbers. So you can plug in a half, negative 1000, positive whatever, you will get an output which will be the y value. So the next thing to talk about will then be the range. So the range of a function is the set of possible y values. The set of possible y values. So we're gonna use the same example up there, right? So the range is all the y values the function can produce, right? So if you plug in any value into this x squared function, you will never get a negative number. That's why this graph doesn't go to the negative side of the y axis. It only goes to the positive side of the y axis. So already we can tell that our range is the set of all positive numbers for that specific function. This one, our function g. So the range is all y values the function can produce. So if domain is the input, then the range is the output, right? So if we use our function f of x equal to square root of x again, since square roots are never negative, the range will always be y greater or equal to 0, even for that specific function, right? So range tells you what results are possible. The next important thing to know is 3, the axis of symmetry. Axis of symmetry. So with the axis of symmetry, you can imagine folding the graph in half and both sides match perfectly. So the line you fold along is the axis of symmetry, right? So we even have this on, let me quickly write down the definition of the axis of symmetry. So this is an imaginary line that divides a graph into two mirror images of each other. So we'll go more into detail when we do the actual functions one by one, to understand what the axis of symmetry does. Sometimes you'll be asked to do an equation for a specific axis of symmetry and all. So for example, for parabolas, it will always be just a vertical line that can divide the graph into two equal half. The graph that we use, the g graph above, g of x is equal to x squared. This graph is perfectly balanced around the y-axis. You can see this part is the mirror image of this one along the line y. So that's all for the axis of symmetry. Let's do 4. The next important term to remember is the maximum of a function, which is the highest possible y value. So you can just say think of it as the highest y value the graph reaches. Yeah. So if you climb the graph and reach the highest point before going down, that is the maximum point. It's the point at which you change the direction. You will see it when we do, I think we talk about it more when we do cubic functions, when the rate of change changes from negative to positive, positive to negative, local maximas and local minimas, which is stuff that we're still gonna discuss later. And the minimum value will be next. Minimum. So this is the lowest possible y value of a function. So again, if you move along the graph and reach the lowest point before going up again, that point is the minimum value. For example, here, if you were moving this way, before you go up again, just here, you are at the minimum, which is the lowest point of the graph. Right. So it's it's a y value. The next one, 6, okay, will be the asymptote. So this is the an imaginary line that you are not allowed, the graph is not allowed to touch at all, right? So we usually see this line for hyperbolas and exponential graphs, right? So an asymptote is basically a line that the graph gets closer and closer to, but never actually touches. I'll give an example just now. So imagine if we had an exponential function like this. Y-axis, x-axis. So this graph coming from this direction, the negative gradient, it can get closer and closer to the x-axis, but will never touch the x-axis, right? So it can get closer and closer, but we just draw an arrow to show that it continues. So it should never touch. So that means the x-axis in this case is the asymptote of this graph, right? So the asymptote of this graph, remember we call the x-axis line y equal to 0 because y is 0 anywhere here on this line. So that will be the asymptote of this graph. Let me quickly give the definition. So this is the line that the graph gets closer and closer to, but never actually touches. Yeah. And the last one will be the turning point. So this is basically where the graph changes direction. Where the graph changes direction. My handwriting is bad. So for example here, this lowest point is also a turning point because the graph changes direction from the side and then going down on the left, and on the right it starts going up. So that's the turning point. You'll see with cubic functions we have 2 turning points, local maxima and local minima. Yeah, we'll discuss that in another video. So these are all the important terms you need to remember before you go directly into functions. And the next function that we're gonna do will be the linear function, which is your straight line.